Hello, in this session of qualitative analysis, we evaluate the test for anions. Welcome. As stated, anions are negatively charged ions such as chlorides, nitrates, carbonates, sulfates, phosphates, and so on. To be able to test for anions, we need unique test agents such as lead nitrate, silver nitrate, barium nitrate, lead acetate, potassium manganate 7, potassium dichromate, and so on. However, in order to effectively conduct tests for anions, the principal reagent is dilute nitric acid. This is in the sense that dilute nitric acid provides nitric ions which dissolves all present cations into solution, thereby making them free and delocalized and ready for interaction with other test agents. In this case, therefore, before conducting a test for anions, you normally treat the sample with dilute nitric acid and then proceed with a select option of a reagent which is going to give a confirmatory test for the ions present. Let's take a look. So, as you can see illustrated on the board here, the leading test agent is silver nitrate. Now, silver nitrate is used for testing for the halogens in the sense that when silver nitrate meets chloride ions, it forms characteristically a white precipitate. Now, the shade of white seems to fade, and when you add bromine, it will give us a creamy precipitate. And equally, when you add iodine, it gives a yellow precipitate. Therefore, we can say that silver nitrate precipitates a white substance with chlorides, it precipitates a creamy substance with bromides, and it precipitates a yellow substance with iodine. These are our respective precipitates for the halogen species. Next, we have lead nitrate. Now, lead nitrate is also used for the testing of chloride ions, but then it gives identical result with carbonate with only a slight distinction in the sense that when lead nitrate is added to chloride ions or suspected chloride ions, it will form a white precipitate, but the precipitate will dissolve on warming after adding excess of the nitric acid. On the other hand, when lead nitrate is added to carbonate ions, it will also form a white precipitate. However, that precipitate will remain undissolved even in the addition of excess nitric acid and warming. Therefore, in summary, silver nitrate and lead nitrate can be used for the testing of chloride ions. When silver nitrate is used for testing chloride ions, it forms a white precipitate which is insoluble. When lead nitrate is used for the testing of chloride ions, it forms a white precipitate which is soluble on warming after adding excess of dilute nitric acid. Next, we have a barium solution. Barium solution may be in the form of barium nitrate or barium chloride. Now, whichever it is, barium solution is used for the testing of sulfates and sulfides. In this case, the sulfate ions will form white precipitates which are insoluble, while the sulfide ions will form white precipitates which are soluble in barium solution. Remember, we have said barium solution is either barium nitrate or barium chloride, and they are effectively used for the testing of both sulfate and sulfide, where the sulfates form white precipitates insoluble, while the sulfides form white precipitates soluble in excess dilute nitric acid. Next, we have lead acetate. Lead acetate is uniquely used in the test for sulfide ions. Remember, sulfide is from the element sulfur, while the sulfide is a subset of sulfate from the radical, which is the ultimate radical of the oxide of sulfur. Therefore, the sulfide ions are tested by lead acetate, and we expect to see a black shiny precipitate. Beyond this, we have other test agents which I wish to evaluate in an equal break, and you'll bear with me just to clear this, and then we see what we expect with these other test agents that I'm about to introduce. So, as mentioned, whenever you're testing for anions, the principal test is the addition of dilute nitric acid to separate the ions so that you have delocalized anions in solution. And in this case, therefore, we are going to take on the ion 2 sulfate in buffer with the concentrated sulfuric acid This one is used for the testing of the nitrate ions, and what it forms is a brown ring precipitate. Remember, when conducting the test for nitrates, the test tube has to be held in a slant position while adding the concentrated sulfuric acid so that the reaction does not lead to spurting out that may lead to injury on the face. Therefore, we are saying that the test for nitrate is simply iron 2 sulfate in buffer mixture with corn sulfuric acid, and it forms a brown ring referred to as a brown ring test for the nitrates. Next, we have the oxidizing agent, namely potassium manganate 7. The potassium manganate 7 may be used for the testing of any reducing agents. Next, we have potassium dichromate, and potassium manganate 7 is purple in color, while potassium dichromate is orange. Now, when you use these substances, we expect them to be testing for what we are referring to as the reducing agents, namely sulfides. It could be alkanols or unsaturated hydrocarbons. In each case, the test procedure is the same. Therefore, what do we expect? Whenever you use the oxidizing agents, namely potassium manganate 7 or potassium dichromate, we expect them to decolorize reducing agents such as sulfides, alkanols, and unsaturated hydrocarbons such as alkenes and alkynes. In this case, alkynes are triple bond molecules, while alkenes are double bond molecules. So the purple potassium manganate 7 is decolorized to colorless, while potassium dichromate is changed from orange to yellow. So it changes to yellow or sometimes to green depending on the concentration of the solution applied. Next, we have bromine water, and bromine water is simply bromine dissolved in water which appears as aqueous bromide. In this case, it is also used for the testing of reducing agents such as sulfite. It tests alkanols, and it tests the unsaturated hydrocarbons such as alkenes and alkynes, and again it is decolorized. It happens to be pale yellow or reddish brown and turns pale yellow. Good. Now, beyond this, we have other tests which are used for identifying the carbonyl molecules. Carbonyl molecules are found in what we refer to as alkanoic acids or carboxylic acids. They are also found in what we refer to as aldehydes and also in what we refer to as ketones. While ketones are secondary hydrocarbons, aldehydes are primary hydrocarbons. So this is the nature of what we are referring to as the test for carbonyls. So to test for carbonyls, as we are going to see, we are going to use three principal tests. If you allow me, I represent the carbonyl here. So we may use what is known as the tolerance reagent. And the tolerance reagent in this case is silver nitrate. Now the tolerance reagent with the carbonyl will give us a silvery glassy precipitate. Now this is true only in respect to aldehydes, which are the primary carbonyl carrying molecules. However, when it comes to the other secondary carrying carbonyl molecules, it will give a negative test result in the sense that there will be no reaction realized for aldehydes. Next, we have the Fehling solution. Now, Fehling solution is simply a solution made up of copper ions and which may be in hydroxyl forms. And in this case, the Fehling solution will test the carbonyls, and it will give us a condition whereby the blue solution turns orange. Remember, copper ions are blue, so the blue copper ions in Fehling solution will turn orange if the carbonyl present is primary. However, if it is secondary, we would not expect a reaction to occur. Finally, we may use what is referred to as the iodoform test. And the iodoform test is in the same class of toluenes and Fehlings. In this case, the iodoform test is just a halogen, whereby the reaction with a primary hydrocarbon is effectable, while reaction with secondary hydrocarbons is non-effectable. So in summary, therefore, what we have seen here are the test agents and how they are applied in the testing for anions. In summary, we have said that chloride ions are tested by silver nitrate, whereby they form a white precipitate, which is insoluble. They are also tested by lead nitrate, which forms a white precipitate that dissolves on warming after adding excess dilute nitric acid. Beyond the chloride ions, we looked at the bromide and iodide, which are also tested or testable by the silver nitrate. And we saw that the bromide ions forms a cream solution, while the iodide ions forms a yellow precipitate. And next, we were able to look at the test for sulfates and sulfides, and we say that the sulfates and sulfides are tested by barium solutions, namely barium nitrate or barium chloride. In each case, they form white precipitate, but where there is a sulfate, the white precipitate is insoluble, and where there is a sulfide, the white precipitate is soluble. Next, we have looked at the test for nitrates, and we have seen that nitrates are tested by iron 2 sulfate, followed by Kong sulfuric acid, where it forms a brown ring precipitate at the interface of the liquids. And we say that that test has to be conducted with the test tube in a slant position to prevent the spurting out of the sulfuric acid when it meets or comes into contact with solution. And then we have seen how the oxidizing agents are used for identifying the reducing agents, namely potassium manganate 7, potassium dichromate, and bromine water. Whenever you add a reducing agent to the oxidizing agents, they end up decolorizing the oxidizing agents, signifying the presence of sulfides, the presence of alkanols, and the presence of unsaturated hydrocarbons such as alkenes and alkynes. Beyond that, I have simply introduced what is known as the test for carbonyls by using toluene